This is a tutorial on how to use the z-test for two samples using Excel with its data analysis toolpak. So we have here a sample problem. A construction firm is evaluating two cement suppliers, so we have supplier A and supplier B, to decide which one provides concrete with higher compressive strength. So this is our clue, the two suppliers, that this is a two sample problem because we have two different cement suppliers, supplier A and supplier B. So that is the clue for two samples. So the engineers collect 20 samples from each supplier, so 20 cement from supplier A and 20 cement from supplier B, and measure the compressive strength in megapascal of concrete cylinders. Assume that the population standard deviation is known and equal for both suppliers, which is equal to 1.2 megapascal. So based from the problem, we are given the population standard deviation. So if we are given the population standard deviation or the population variance, we can use the z-test. So if we will combine the two clues, that this is for two samples because we have supplier A and supplier B, and we are given the population standard deviation, so this is a z-test. So this test is a z-test for two samples. So here are the different concrete sample compressive strength of the concrete cylinders from the supplier A cement and using the cement from supplier B. So the question to be answered is, at the 5% significance level, is there a significant difference in the average compressive strength of the concrete from the two suppliers? So we want to know if there is a significant difference. So let's write for the given. So we have two suppliers, supplier A, supplier B. Then each supplier has 20 concrete cylinders. So 20, 20. Then the population standard deviation based from the problem is also equal for the both suppliers, which is 1.2 megapascals. So we need to calculate for the population variance based on the given standard deviation. So that is simply the square of the standard deviation. So we will just square this. Same with this one. So mathematically, they also have same variance because their standard deviation are the same. Then the alpha, or the level of significance for this test, is 5%. Or 0.05. Then next, let's write its hypothesis. So we have the HO and H1, or the null and alternative hypothesis respectively. So for the null hypothesis for two samples, this is always there is no significant difference between the two samples, so there is no effect or there is no difference. So simply we can write here that the compressive strength of the cement cylinders from supplier A is equal to the compressive strength of the cement from supplier B. So their compressive strengths are equal, meaning there is no difference. Okay. So for H1, that is the negation, or that is the question we want to answer. So We will read again the question. So at the 5% significance level, is there a significant difference in the average compressive strength? So we just want to know if there is a significant difference. So this is a non-directional alternative hypothesis, meaning we can use the not equal for the alternative. So compressive strength of the cement cylinders from supplier bay is not equal to the compressive strength of the cement from supplier B. So these are hypotheses. So in order to decide if we reject or do not reject the null hypothesis, let's do the z-test. First is different datas. So I will put a label before the datas to make sure that we are going to use the correct data. So let's copy this data. So these are the data from the supplier A. For supplier B, let's do the same. There. So after we type or copy the data in a single column, we go to the Data tab, then Data Analysis. Choose for the z-test 2 samples for means. Click on OK. For the variable 1 range, so we can choose the data from the supplier A, so that will be our variable 1. So I did not include or I did not highlight the label, only the data. Then for the variable 2 range, do the same for the 20 data for the supplier B. Then for the hypothesized mean difference, because our null is no effect or no significant difference, this should be equal to 0 because we have 2 samples, and we based from the null, they should be the same. So the hypothesized mean difference should be 0. For the variable 1 variance, so let's check the variance of the supplier A because that is our variable 1, so that is 1.44. Then for the variable 2, the variance of the supplier B, which is also the same, 1.44. Then for the labels, I will not check this because I did not highlight the labels when I choose the data for the input. Then for the alpha, it is 0.05, so we do not need to change this. Then for the output range, so we can choose any blank cell for the result. Then click on OK. So here is the result. So we have the result for 2 samples per means. So for the variable 1, here it is supplier A. For variable 2, this is the supplier B. So the mean for the variable 1 or the supplier A is 30.35 megapascal, and for variable 2 that is 29.805. So they have same variance, and the observations is the number of sample, which is 20. So the hypothesized mean is 0. And for the computed z-stat or z-value, that is 1.4362. So we will choose if this is one tail or two tail. So based on our alternative hypothesis, because we have the non-directional alternative, this is a two-tailed test. So this is a two-tailed test, so we will choose the z critical for two-tail. So this is our critical value. So if we will check the bell curve and the critical region, this is our critical region. So the critical region for two-tail, that is positive and negative 1.96. So this is the color blue region. Then our z value computed is 1.43. So this is the red line here. So if we will check the figure, the z computed or the z value falls under the unshaded part, meaning our decision should be, because it falls on the unshaded part, the decision is do not reject HO. So for our conclusion, so we will answer the question. So at the 5% level of significance, there is no significant difference in the average compressive strength between supplier A and supplier B. So there. So that is our conclusion for this test, because we did not reject the HO, so there is no significant difference in the average compressive strength between supplier A and supplier B. Or if you want to use again the alpha, so our alpha is 0.05, then we will compare that with the P for two-tailed, so that is 0.15. So the computed P or the P value, so this is the P value of the two-tailed, 0.15 is greater than 0.05, so we do not reject HO. Next example for z-test for two samples. So we have here a construction company uses concrete from two different plants. So we have different plants again. So this is a two sample. So we have plant A and plant B. The company claims both plants produce concrete with the same average strength. To verify this, engineers randomly test 30 cylinders from each plant. The population standard deviation is known to be 0.8 megapascal for both plants. So the sample mean compressive strength for plant A is 30 megapascal. Then for plant B, it is 29.9 megapascal. So the question is, at a 5% level of significance, is there a significant difference in the mean compressive strength of concrete from plant A and plant B? So, given is the population standard deviation, so this is a z-test, and we have two plants, so this is for two samples. So let's write first the given. So we have plant A and plant B. So each plant has 30. So the same 30 samples. Then their population standard deviation is also the same, which is 0.8 megapascals. So for the population variance, so we need this later for the z-test, that is the square of the standard deviation, so we need to square this one. Same for plant B. So mathematically, they have equal variances again. Then for the sample mean of the compressive strength for plant A, so this is the sample mean. Plant A has 30.5. Then for plant B, it's 29.9. And the given level of significance is 0.05 or 5%. So we need to write the HO and H1, or the null and alternative hypothesis respectively. So the null hypothesis, so this is always there is no significant difference between the two variables, or the compressive strength of plant A is equal to the compressive strength of plant B. Then for the H1, so we go back to the question. So we want to know if there is a significant difference in the mean compressive strength. So again, this is a non-directional, so we can use the not equal. So it did not specify if the engineers want to know if plant A is stronger than plant B or plant A is weaker than plant B. So they just want to know if there is significant difference. So we can simply use the non-directional alternative. So compressive strength of plant A is not equal to the compressive strength of plant B. So because this is our alternative, a non-directional, this is a two-tailed test. So now we should be writing or typing the different data in a single column for each plant. So here for plant A, then at its side the plant B. But if you will notice, the problem did not give us the different values for the 30 samples, but we have the mean or the sample mean for both plants. So if we are given, or we are already given the sample mean, we can do what we have done in the previous video for the z-test for one sample. So we will just copy the sample mean 30 times because we have 30 samples. So here 30.5, and for the plant B 29.9. So we will just copy this 30 times to have a 30 observations or 30 samples. So there. Then if we have already done this, we can use the z-test for two samples in the Excel. So we go to data, then click on data analysis, choose z-test for two samples. So I will just delete this first. So for variable 1 range, I will highlight the data under the plant A. Then for variable 2 range, the data from plant B. The hypothesized mean, so this is always 0 if we have two samples. For variable 1 variance, so the variance from plant A, which is 0.64. Then the same with plant B. Then labels, I will not check this because I did not highlight the labels when I choose this data. Then for the output range, so we can choose any blank cell for the result. Then click on OK. So here is the result. So we have variable 1, then variable 2. So the mean for variable 1, 30.5, which is also the same with this one. For the variable 2, 29.9. So we did not change the mean of the two plants. For the variances, so it is the same, 0.64. Then we have 30 observations from each plant. Then the hypothesized mean is 0. So the computed z value is 2.9047. Then we will choose the z critical. So this is a two-tailed. We already have identified it. So we will choose this as the critical value. So if we will check the critical region, So here is our critical region. So it is the same two-tailed with the previous problem. So we have the positive 1.96 and negative 1.96. And the z value computed, which is 2.9047, that falls in the right tail of the critical region. So you can see it here. So if it falls in the critical region, our decision is we reject HO. So the conclusion from our decision to reject the HO, we conclude that at the 5% level, oh sorry, this should be 5%. At the 5% level of significance, there is a significant difference in the average compressive strength between concrete from plant A and plant B. Yeah. So our conclusion, at the 5% level of significance, there is a significant difference because we rejected the null hypothesis. So this is how we use the z-test for two samples in Excel.